Good day, everyone. You're welcome to my YouTube channel at SMDexecutive Academy. If this is the first time you are coming across my video, kindly share, like, and subscribe to my YouTube channel. All right, in this video, we'll be discussing about the conversion of galvanometer to ammeter. How can we convert galvanometer to ammeter? So we have a question which we're going to use to treat this particular topic. So we have a question on the board which says that the diagram below rather illustrates the conversion of a galvanometer of resistance 2 ohms to an ammeter. The galvanometer gives a full-scale deflection for a current of 10 milliampere. Calculate the value of the resistance of that shunt. Now, for us to convert galvanometer to ammeter, what do we need? We need a shunt of low resistance value to be connected to the galvanometer in parallel. So if the galvanometer is connected to the shunt in parallel, it simply means that the current supplied to get into the galvanometer will be shared between the galvanometer and the shunt. What is a galvanometer? A galvanometer is that device or an electronic device which is capable of measuring current only in small quantity. That is why you will see the galvanometer here is deflecting a full-scale deflection of what? 10 milliampere. So a galvanometer can only measure current in milliampere, while an ammeter can measure current in ampere. So for a galvanometer to be capable of measuring 1 ampere, it has to measure that current 1,000 times. So which tells us that 1,000 milliampere makes 1 ampere. So this galvanometer can only measure 10 milliampere, and there is 10 ampere coming into the galvanometer. There, which means if this 10 ampere gets into the galvanometer, it is going to damage the galvanometer. So we need to connect a shunt to it in order for us to be able to measure that 10 ampere. So if you are connecting the shunt to it, we connect the shunt in parallel to the galvanometer. So as the current is coming in, the 10 amperes is coming in, the galvanometer can only measure 10 out of the 10 ampere. So 10 milliampere out of 10 ampere. This 10 ampere is equalizing 10,000 milliampere, because 1,000 milliampere is equals to 1 ampere. Then, which means that if you are given 1 ampere. So if you are given 10 ampere is equivalent to 10,000 milliampere. So 10,000 milliampere is coming in. Out of this 10,000, this galvanometer can only measure 10 out of the 10,000. So which means it's too much for the galvanometer to measure. So the remaining of these 10,000, after the galvanometer has taken its 10 away from it, we are left with 9,990 milliampere. So 9,990 milliampere we get into the resistance, which is called into the resistor, which is called shunt of a low resistance value. So what will be the value of this resistor that is capable of taking away 9,990 from this 10,000? That is what we are calculating here now. So in a series or in a parallel connection, current is shared. In a series connection, current is the same. So the current that is coming in here, we have explained that is shared, but the voltage coming along with the current will be the same in each component. So if the voltage coming in here is V, then the voltage that gets into this galvanometer will be V. Then voltage that gets into the shunt is going to be V. So we can say that the voltage of the galvanometer, V, is equals to current of the galvanometer times the resistance of the galvanometer. And also the voltage of the shunt is equals to current of the shunt times the resistance of the shunt. So I'm not making this specific because the voltage that enters into the current, into the resistor or the shunt, will also be equal to the voltage that we enter into the galvanometer. So if the voltage is the same here, then we have to equalize the volts. So we can say now that therefore V must be equals to V. So if V of the galvanometer is equals to the V of the shunt, then the multiple of that result has to be equal to each other. That will be current of the galvanometer times the resistance of the galvanometer equals to current of the shunt times the resistance of the shunt. Now we have gotten this. So we just have to insert the data and get the resistance value of the shunt. So what we'll do to that is that now we have two. Okay, let's just manage what we have here. All right. Erase this, and we have the I galvanometer times resistance galvanometer equals to current of the shunt times resistance of the shunt. What's the galvanometer? The current of the galvanometer is 10 milliampere. That's 10 milliampere. So we have 10 milliampere times the resistance of the galvanometer, which is 2 ohms. That's 2 equals to current of the shunt, 9,990 times resistance of the shunt, which that is what we are looking for. So making the resistance of the shunt subject of formula, we have 20 here equals to 9,990 resistance of the shunt. Therefore, 9,990 resistance of the shunt equals to 20. So with this, we have Rs is equals to 20 over 9,990. 9,990. So if I were to bring this down to, we have 0 cancel 0, we have 2 over 9,999 ohms. So it is obvious that when you divide this 2 over 999, you'll be having an equivalent of 0.00. So which tells us that that is what? That is a very low resistance value, which is called shunt. I hope this video has explained exactly how to calculate or how to convert galvanometer to ammeter.